Hello, welcome to my channel. Welcome to Embedded Systems Practical 5. In this practical, we'll be dealing with Introduction to Home Automation. Then we'll go into our major practical for the day, which is over under voltage, monitor, and alarm system. If this is your first time of visiting my channel, please subscribe to my channel. Hello, welcome to Embedded Systems Practical 5. In this practical, we'll be dealing with Introduction to Home Automation. Then we'll take a look at a practical construction, which is over under voltage monitor and alarm system, which I have designed and constructed for myself. So before we start our lesson for today, let's have a basic understanding of what home automation is. We will start by knowing what is automation. Automation is the use of machines or technology to perform tasks without human intervention. So that's the use of what machines or technology to perform tasks without human intervention. Then putting that together, home automation. Home automation is a technology involved in creating or developing machines or systems or devices that trigger automatic functions for home devices. Examples of home automation. We have automatic security light controller. We have automatic voltage monitors. We have automatic proximity intrusion alarm. We have automatic water pumping controller or pumping system. We also have automatic garden irrigation system, automatic battery charger, automatic fan speed controller, automatic doorbell ringer. The list, there are more. So these are a few examples of home automation. Let's also take a look at this in industrial automation. We have home automation, we also have industrial automation. This deals with the use of computer control systems such as robots and programmable logic controllers, PLC, to operate industrial processes or machinery, reducing the need for human intervention. A very good example is the automatic teller machines we all know about. Now, if you look at the home automation, that word automation, automatic, making something to work without you going there physically to control it. Just like the first example we have here, the automatic security light. Normally, when it's getting dark, the user have to go and turn on the switch to turn on the light. But in this case, we want the light to automatically come on when it's getting dark. So you can see this word automatic. This one, all these examples listed here, there is no human intervention. They automatically control themselves. Like this one you see here, automatic battery charger. Under normal circumstances, you will be using a voltmeter to be checking the voltage of the battery. If the battery is fully charged, you disconnect it to prevent further charging. But in this case, this device, once the battery is fully charged, it will auto disconnect it from the charging system. So you see, so all these are things we use around the home. So we have it home automation. So you see there, home automation. Then from the other side, you look at the industrial automation. We'll be dealing with industrial machine. So that the automatic teller machine, you can see this machine sitting right there from Monday to Sunday, attending to customers without any human intervention. So this ATM is an example of industrial automation. Apart from the ATM, we also have industrial welding robots in the car manufacturing company. Then we also have all those in the bottle manufacturing companies. Also, we have machines that are being automated to be carrying out tasks without the need for human intervention. So let's go to our our practical that we're going to be dealing with for today. So this is just a block diagram of a simple home automation, the simplest home automation system you see here. We'll need sensors, some sort of sensor that will collect data. Then we need processing, the data need to be manipulated. Then we need an actuator and an output. So what the sensor does that it collects data, the controller manipulates the data, then the actuator reacts to the data. Then this system they need power supply because these are all electronic systems. Now you know that our computer is electronic, built up, made up of electronic components. So let's so here I have the block diagram of what I have here, which I have designed. I have done the finished construction, the remaining packaging. So I will be explaining this. Well, let's take a look at the block diagram. So this block diagram of under voltage monitor and alarm system. So before we go into what is this voltage monitor? Voltage monitor. Now in this case, we are dealing with AC voltage here, 220 volts. Now, most of it that uses gadgets or electronic appliances or equipment that connects to your 220 volts AC source. Now, sometimes the voltage is not steady. Sometimes the voltage might go high, go beyond 220 up to 250, 260, which is very dangerous for our gadgets, for electronic appliances. And sometimes the voltage might go low, below 100, which is also not good. From personal experience, I have experienced high voltage from damaging some of my electronics. So that made me to design this system. So I also want you guys also to learn something from it so that you also can design your own system. Now, we have some popular gadgets like that does similar thing to what I'm doing in the market. One of the common one, we call it a TV guard. But this one has far more functions more than the one we have in the market. Now, it's not just sometimes going to market to buy what we need. Now, as an engineer, as an embedded systems engineer, it's not everything that I will be expected to go to the market to buy. What is the essence of me learning engineering in school? So I find joy in designing my own stuff myself. Even if this is going to cost me more than the ones that are available in the market, I find joy and I'm happy to be able to put something together, customize it to the way I want it. The ones that are available in the market, you cannot customize them because the manufacturer designed them. That is how they operate. But this, I want whatever feature I want in it, and I made it to be that way. So let's take a look at this. A block diagram. Now, first developing any system, we need to put drawing diagrams is very, very important. It's very, very important. For those of you if this is your first time of visiting my channel, I've treated embedded systems. I've talked about embedded systems, so please go and watch my previous videos. And also please try your best to subscribe to my YouTube channel if you have not done so. And also please like and share this video. This is a block diagram of this system we have here. So what does this system do? Which I'm going to explain here. Voltage monitor. That is a device that checks the level of voltage, either the voltage is going beyond a certain range. So that's also what the voltage monitor does. We have here over and under voltage monitor, an alarm. If the voltage goes beyond a certain range, the load should be disconnected quickly, and then an alarm should be sounded, preventing damage. You know, the safe voltage for our electronics gadgets, those gadgets that are designed to work on 220 volts. So if your voltage go up to 245, it is not going to damage those loads. But when it go beyond 245 volts, it could damage most electronics, it could damage them. And also under voltage, that is, there are some of our electronic gadgets that can operate at 100 volts AC. For example, our laptop chargers. If you check your laptop charger, is from 100 to 240 volts. So if your voltage is 80 volts and you still connect your laptop charger, you are going to destroy your laptop charger. And also the voltage goes above 45 volts. You're also going to destroy your laptop charger, and not just other electronics also. So this device, these systems here, this system that you are seeing here will uh, will prevent high voltage from destroying your electronics. It is better for your electronics to be turned off than to get damaged. So if the voltage go over, now this system here is adjustable. Just like you can see, it is adjustable. As you are seeing these two adjustable, which I'm going to explain later. This system is adjustable, so to any range you want it to, within the safe range you want. So for example, now I will set up this system such that if the voltage goes above 245 volts, the load should be disconnected immediately. An alarm, a warning alarm should be sounded so that the user will know that the voltage is unsafe. And also if the voltage goes below, let's say 100 volts, the load will be automatically disconnected and an alarm will be sounded to alert the user that the voltage is unsafe. So in this way, your electronics will be protected. So let's take a look at how the units are linked together. Now we have a high voltage reference point. We also have a low voltage reference point. These are adjustable. And then we have the input voltage, the varying voltage that will be monitored. So via voltage sensor, all these three stages, they have sensors that we have here, voltage sensors. These two are just going to be potentiometers here. Why this? We have a AC voltage sensor. So just something like this. Yeah, this is also the voltage sensor. But here I designed mine, but I didn't use it. So this is also a voltage sensor that you can also use here. So let's take a look at it. Then here we have a microcontroller. Microcontroller. So here I have let me pull this out. So this is a 32-bit STM32 microcontroller board. So this is a microcontroller board. Here we are. This is a microcontroller you are seeing here. Here is for programming, where you write your software and you download the software to control this. So with this, the microcontroller I used is this STM32. That's the computer in here. So then we have alarm, an audible alerting system. Then we have visual indicators, LEDs. Then we have a relay. This one's responsible for switching the load. Then we have our input supply, 220 volt AC that's going. Then we also have a DC voltage that will power the electronics and the microcontrollers. So let's take a look at the circuit diagram. So this is the circuit diagram that you have here. This is the circuit diagram. Let's erase this so you can see it clearly. Okay. So what you're having here, this is a complete circuit diagram of this over voltage and under voltage monitor that you see here, which I have finished constructing. So let me explain the circuit to you. So let's take a look at this. From here, this is the microcontroller. You can see the microcontroller we have here. That's the STM32 microcontroller, which you are seeing here. So let's take this so that you can see them clearly. So this is the STM32 microcontroller, and the whole of this is the microcontroller board. So you see, so that's what we have here on the diagram here. Then the whole of this is my voltage sensor. I built this, I designed this from scratch. This is my own version of voltage sensor. Others use transformers. You can use transformer to do this also. But yeah, I use this is an optocoupler with non-polarized capacitor and polarized capacitor and some diodes and then some resistors here. So this goes directly to your 220 volt source. And then on the other side, the optocoupler is powered with. No, this microcontroller uses 3.3 volts. So, so that's the reason why you power it with 3.3 volt. If your microcontroller uses 5 volts, you power it with 5 volts. So this microcontroller here, this power works with 3.3 volt. Although there is a voltage regulator, 5 volt to 3.3 volt regulator on board, so which means I can still power it from 5 volt from this point. The voltage, the 3.3 volt regulator is going to provide the 3.3 volt that powers the microcontroller, because the analog inputs are 3.3 volts, so that's the reason why I'm powering it with 3.3 volt here. So this is the output. So if there is voltage in here, there's also going to be voltage in here. So here your voltage between 0 to 220 volts, between 0 to 400 volts. Then here you have between 0 to 3.3 volts. So a corresponding increase in voltage as there's increase here. As the voltage decreases here, the voltage also decreases here. So this is my voltage sensor that you see here. Let me show you on the circuit board. You can see it. You can see it here. You can see the diodes. You can see the optocoupler. Then the polarized and non-polarized capacitors, those two resistors, 220k resistors, you can see here. Then my 4.7k resistor, non-polarized and polarized capacitor. So this is the output that goes to the analog input. So you can see it. So you can see them here. Then we have, if you look at our, let's go back to our block diagram. We have high voltage reference, low voltage reference, then input voltage. So this is the input from this sensor here. You know, these are potentiometer. They also will be used as sensors here. So here, this potentiometer here is for setting up the high voltage reference point, while this one is for setting the low voltage reference point. Because this microcontroller, I programmed it to be comparing this voltage with this, also comparing it with this. If this voltage is greater than this, it means that high voltage is being sensed. If this voltage is lower than this, it means low voltage is being detected. You understand? So as long as this voltage here is in between this range, the high and the low range, then no high voltage, no low voltage is being detected. So let's look at this again. The next ones here, we have LED indicators. Now if you check our diagram here, we have LED indicators. So these are LED indicators. So these are the, you can see them, LED indicators. Then we also have a buzzer alarm. So look at the buzzer here. This one here is the buzzer. And then we also have a start button here. You can see, although I'm going to replace this with a bigger one, so you can see this push button. Then we also have auto and manual mode indication. So we have automatic and manual mode switch. So look at it here. So if I put in this way, the system is going to be manual. Manual means that once there is AC voltage, I'm not around and my gadget are still connected to the outlet, no power is going to go to my load. My load will remain off. So I'll be the one to press this button, then the system is going to turn on and check the voltage and power my load. But if I don't want it, I want it to be in automatic mode. Whenever there is AC supply, the system is going to come on automatically, check the voltage. If the voltage is okay, send out power to my loads. So that's what this switch is doing here, is to select both automatic and manual mode. Then here we have the relay. This guy is what is responsible for cutting off power from between the load and the source, or sending power from the source to the load. So that's what the relay does here. So this is the relay that I have here. This 100 amps, 12 volt, 100 amps automobile relay. So I use a high current. So if you see this cable that I use here, this 4 mm cable I use very thick because I want something. So this is just for my electronics. Now if you're going to power the whole of your house with, you can't use this to power the whole of your house. If you want to power the whole of your house with this system, you're going to use contactors. Use this relay is going to drive those heavy contactors. So the contactors will be the one that drive your load. But in this case, just for my electronics, you understand? So with this 100 amps relay is okay for that. So you see, so this is 100 amps relay that you have here. And then the relay is driven by a transistor here. Look at transistor here. And then control received from the microcontroller. So here, these are the sensors. These are the sensors. You can see the two potentiometers here. The high reference point and the low reference point. That's the high voltage reference point and the low voltage reference point. So it's adjustable. So I can adjust it to any, okay, if it is 230, I want it to sense high voltage, or if it is 250, it will depend on which range. So here too I can adjust, is it 90 or is it 80 volts reference points, you understand? So these are for adjust. You can set the range yourself. So this is a transistor we have here, my buzzer. So the transistor you have my buzzer. Now the whole of this, how do I power the whole of this? How do I power this entire circuit? So let's look at the power supply. So this entire circuit is powered with 12 volts. So so these two cables that you're seeing here, this 12 volts and the ground. So you see 12 volt and ground. I can power the entire circuit with 12 volts. So this is the sensor input, the AC voltage sensor from the AC voltage. So AC voltage is going to go in from here. So here I will have my 220 to 12 volts, 220 volt to 12 volt DC adapter. So you can see it here, which I will use to power the circuit. So this one you have here is one that is going straight to the incoming 220 volt AC, which you have here. So this is your AC voltage source. So you see the wiring here. Your relay is connected in series with the load and the source. So this is your source and then this is the load. So that I have to put it, I'm going to put a socket outlet, like 15 amp socket, where I will connect my extension socket going to my appliances here. Then, so from my 12 volts to 20 volt AC to 12 volt adapter, yes, or power module, I have here 12 volts. So my 12 volt comes in here, just like what you are seeing here now. My 12 volts, my ground. So you see, so now I'm powering this board with 5 volts. I've mentioned that the board itself, it has a 3.3 volt regulator. Actually, the microcontroller is 3.3 volts, but the board have 5 volt regulator. So that's the reason why I'm just having a 5 volt regulator here. And also the buzzer is, so I'm powering with 5 volt. Now, since my relay is 12 volt, it's taking it from this 12 because my power module here is 12 volt DC. So from this 12 volt, I can power the relay, which is 12 volt. So since my microcontroller I have a 5 volt terminal on it, so I'm going to use a 7805 regulator here. Look at it here. This is 7805 volt regulator. First, take a look at the capacitors I put here. So which is what you have here. So this is the input of the regulator, this is the output. For the output is 5 volt. No, this 7805, take note of that. Don't go and use 7905. 7905 is negative 5 volt. So this is positive output, so 7805. Then we also have your polarized and non-polarized capacitance xenon diode. So you can see them all here. Let me show you all. I've covered them up. So okay, I think this is remaining for me to, okay, I haven't connected, but I'm still going to connect them here. I already have this connected, so remaining this and these two, I'll fix them up and I'll connect them up. So this one here is also for, you're going to protect your microcontroller in case of lightning or whatever it is. So I'm going to connect this, but this capacitor is what we have here already connected. So this is how the entire system is. These are the entire system is. So the next video will be after I assemble this. So I assembled. Let me power this circuit from the USB. So this is where it goes to computer for programming. So you can hear the sound of the buzzer. So the system is in automatic mode. So you will see. Now let me restart it. So when I first power the system up, you see the system is in automatic mode. See this light, they're flashing for some number of times for delay. Then it has detected that there is no AC voltage in. The system detected that there is no AC volt, that means there is 0 volt. So it is less than the lower set point. So you can see the buzzer beeping twice and then to give some delay. You can see the relay is off. So in this case now, it has sensed low voltage because there is 0 voltage here on the input. There's no AC voltage in. I just powered it from my USB, so you can see. So it detected that there is no voltage here. So you can see there is no voltage here. So now we're having power outage. I will have power connected this into 220 volt AC source so that you see. So the system, although I've tested the system and calibrating this thing, you need to have some sort of equipment in your lab, a variac. Although I have a variac that I have made, whereby you should be able to have for like 80 to 400 volt AC source, variable AC voltage, so which you are going to use. But if you don't have that, if you have a generator, a small generator, you can increase the voltage to adjust this, because you'll be increasing the voltage, reducing it, and then connect your multimeter to set this. So you see, so it's very technical to be able to set this thing up to that range. So you see, so now there's no volt, there's 0 voltage here, so it is detecting its low voltage. So that means it's not going to trigger any load. So in this case now, this alarm means that there's low voltage. So you see, so my next video will be how I assemble this thing, then how I calibrated, how did I calibrate it, because I want this system to turn off my load if the voltage is higher than 245, or also turn off my appliances if the voltage is below 100 volts. So our next video will be how am I going to set this thing up so that it behaves exactly that way. So you see, so that will be our next video. I'm going to do this. Then I'm also going to take in the programming. You understand? I'm going to take in the program, because this thing cannot work without software. There is software which I have created that is running here. And everything I built myself from scratch, both the software and this hardware. What you have here is both hardware and software. So this what you are seeing here is embedded systems. Embedded systems, that is hardware, controlling hardware using software, computer software. So this involves computer programming. You understand? So our next video, I'm going to uh, show you how I assemble and set this thing up. Then another video I'm going to make, those of you that want to see how I wrote the program, the computer program. I wrote the computer program in Arduino C programming language. So you see, so this is STM32 microcontroller programming board. This is different from Arduino boards. This is not Arduino. This is not from Arduino company, but it's Arduino programming language I'm using to program this. You know, when most people hear of Arduino, their minds go to the board. Arduino is far beyond just the board. It's a programming language on its own. So I hardly use Arduino boards. I use other microcontrollers, but I use Arduino C programming language. So for those of you who have already gone a little bit understanding of embedded systems programming, especially with the Arduino platform, please try and go and get some C programming books and learn them very well, because it's going to be help you. Now, uh, most of you say, why didn't I use Arduino Nano? Of course, I can also use Arduino Nano to do this, but I don't want to rely on Arduino systems. You know, this high-speed processing microcontroller platform like Arduino Uno and Nano, they are all 8 bits. You understand? And the analog input is 10 bits. Now this one is 32 bits, high speed, the higher processing power, and its analog inputs are 12 bits. So it have more processing power than the Arduino. So I use them for most of my project, most of the project I develop for people, I use this. I don't, you hardly see me using Arduino system, so I don't want to be locked up in one particular hardware. I use like ESP32, ESP8266, LGT. I use different, but all still I program them with Arduino C programming language. So just like as I've said, uh, the next video I'm going to show you how I assemble this and how I set this up. I'm going to set the high voltage point and the low voltage reference point. I'm going to finally adjust this thing so that it works how we want it. Just like I mentioned before, we have similar gadgets already in the market. One of the popular one they call TV guard. The monitor is high and low voltage monitor. That's what those ones does. This does the same thing with additional functionalities. There is alarm and is user adjustable. So it's different from the ones they sell in the market. So you see, it's adjusted, user adjustable systems. You understand? So then another issue is if you look at this, if I'm going to use this, how now you can just get your normal 12-volt adapter to power this. You understand? This is switch mode power supply, or you can as well use transformer. No, we have done all those in our previous videos on our practical electronics. So we have done a lot of that. So go and watch my previous videos, or if I wish, I can even use transformers to do this also. So go and watch my previous videos on power supplies. We dealt with AC and DC power supplies. So I'm not going to be drawing that here. So here it just scans. We have power modules like this available in the market, whereby we have your AC voltage inputs, then we have DC voltage output. Some can even go up to 300 volts AC. You understand? So we have them here, and then now this output is regulated. You understand? This output is regulated, so that's why the 12 volt here will take it to power the relay, which is 12 volts. And then this is the unregulated one, which is the one that's feeding the sensor. You understand? So that the microcontroller can be able to know if the voltage is going up or the voltage is coming down. So we also have, just like I've shown you this before, this is also another voltage. What you have here is a transformer. It's a voltage transformer we have here. But I didn't use this. I used my own voltage sensor that I built myself, and it's working very well for me. You understand? So very cheap components. But this with the amount the money you spend in buying this, I will use that money and build about up to 10 of these voltage sensor. They all do the same thing. You understand? The only difference is that this one I'm not using it for reading voltage. It's not calibrated. But this one you can calibrate it to read the voltages. You understand? Read the voltage just like your normal meter, your voltmeter. You can calibrate this to work as a voltmeter. But this I'm not really using it to sense, to know if the voltage is going high or low. You understand? Now, a proportional increase in this voltage will also give you a proportional increase in the DC voltage, which you can view when this is connected to your computer. Your USB connected to your computer, and this thing is powered. It's my based on my program here. It will send the values to your serial monitor. So from here, I can be seeing the values going to my serial monitor. Now, if I connect a real voltmeter here, what voltage will correspond to this value that this is reading here? You can see all the values from the serial. Although I can still calibrate this and make it to work to read voltages, but I'm not using that because I already have my reference point high and low, which in my reply is going to be comparing. You understand? So this I have from the programming is not going to be reading 0 to 3.3 volts. It's also going to be reading 0 to 400 volts. That's what the reading. Both these ones also zero. This one, so they are not going to be reading 0 to 3.3 volts. It's between 0 to 400 volts. So if I take this one up here, it will be reading 400 volts. If I take this down, then it's going to read 0 volts. So this also, as the voltage is going high, increasing here, the value is also going from 0 to 400 volts. That's the interpretation going to be done by the software. You understand? So the microcontroller is comparing this with these two levels. As long as this input level here is between this high and the low, then the relay will be turned on. You understand? This is switch will come this way, the relay will come on and voltage will flow to your load. But once this voltage in here goes above this point which you have set here, it will turn off the transistor and the relay will go back to its original state, and then the buzzer, the alarm will start to sound, and then some LEDs will also be blinking. You understand? So that's how I've developed and I've programmed it, and it's working exactly the same way I've said. So the final this thing, that's after installing this in the casing and everything, I'm going to get a voltmeter. Then I'm going to get a variable AC source so that I will adjust these points correctly. You understand? Just like the way you have inside your voltage stabilizers, there are potentiometers for setting, for adjustment. So I'll use this to adjust, and then the system, so that this will be protecting my appliances from high voltage damage. Now, why now one of the reasons I brought this up is that to share knowledge. Most of our engineering students, those in school, a good number of them don't have passion. A good number of them don't have passion for the engineering they are studying in school. Even the lecturers there, most of them don't even have passion for the engineering. So that's why you see somebody study electronics engineering and he graduates in school. He doesn't even have the idea of anything that has to do with circuit electronics. Simplest electronic circuit, he can't be able to even put off. It's not really just good. You see, so if you don't have passion, by watching my videos, I believe you should develop that interest so that you should be able to design. So at least you should be able to design something. You should be able to. There is no excuse that you give. School is not teaching practical. Everyone knows that it's no longer a new thing. So please take this thing serious. We even have those who are not even from technical background, but some of the good number of them are designing stuff like this. So not talk more of you that is studying this in school and you can't be able to do this. You a lecturer also, please put your interest. This is what you also study in school, and this is what you also lecturing students. So try your best, bring stuff like this and put things together so that you, because the students, they go to the school there for training, not just for the certificate. Because that's what I believe most of us are going to school for, is because of the certificate. So you're engineering student, that should not be your priority or reason why you are in school. You are there to learn engineering, not just the certificate. So please, if you are new to embedded systems and you're having interest in embedded systems, please, I've made videos on that. Get them, go to my previous videos and try and get some microcontrollers. Get your, if you can't get, you mustn't use exactly the same microcontroller I'm using. Just get Arduino, Nano, and Uno. There, I think those are easy to use microcontroller boards. I've made video tutorial that covers them. You understand? So we are going to stop here. We'll see you in our next video. Please, if you benefit from this lesson, please share it, like it, and also subscribe to my YouTube channel. Thank you.